Hello, in this video, we will learn how to construct confidence intervals for a single population proportion. The notation for the population proportion is P. You may realize that we don't really have a condition like we had with constructing a confidence interval for the mean. We studied two situations, one when sigma was known, the other one when sigma was unknown. For this one, it doesn't matter, and you will see why. Sigma is not anywhere in these formulas, so this will be a lot easier and faster. But first, let's talk about the symbols used in this section. P, as I said, is the symbol for the population proportion, while P hat is the symbol for the sample proportion. So P hat is a statistic, while P is the parameter. For a sample proportion, P hat equals X divided by N, and Q hat is N minus X divided by N, or 1 minus P hat. We used this before, and if you don't recall those, let's just make sure we know what these are. We called P hat the probability of success, and X was the number of successes out of the total number of trials, while Q was the number of failures out of the total number of trials. And we said that P hat plus Q hat equals 1. And that's why they have right here, if you want to find Q hat or P hat, you will simply subtract this value from 1. Okay, so X is the number of units that possess the characteristics of interest, and N is the sample size. Now, how do we find the confidence interval for a proportion? Here is the formula. So I will give you a simpler version. P is between the lower bound and the upper bound. Because I'm using P, I will start with a point estimate, which is P hat, and from it, I'll subtract the margin of error, and the upper bound will be P hat plus the margin of error. So you see, it follows the exact same idea that we had for the mean. It's just the notations are different because we are working with a population proportion. So how do we find E? Well, E is right here. I'll write it down right here. E equals, and I'll be using ZC, critical value, instead of alpha over 2, square root of P hat Q hat divided by N. You see right away that because you're using the critical value Z, in this type of problems, we will be using the standard normal distribution or the Z distribution. In order to be able to use this formula, though, we want to make sure that the number of successes and the number of failure are both greater than 10, which means N times P hat, because that will be the number of successes, or N times Q hat, that will be the number of failures, are both greater than 10. Only in this situation, we are able to use the formulas. X is the number of successes. So how do we get this? Well, from here, P hat equals X divided by N. So to solve for X, we multiply P hat times N, and these are the number of successes, N times P hat. Similarly, the number of failures will be N times Q hat. So keep in mind, this is the condition, and only when this happens, we can use the formula. We will now go ahead and do a couple of problems, and I will show you how to use the calculator. In a certain school district, a survey of 350 students showed that 28% carried their lunches to school. Find the 95% confidence interval for the true proportion of students who carried their lunches to school. So let's see what is the given information. You may realize that we don't really have too much information. We have N, which is 350 students, and we have 28% of those that carry their lunches to school. So P hat, it's actually 0.28, and that's it. And the question is, find the confidence interval for P. The confidence level is 0.95, and given P hat, we can figure out Q hat, probability of failure in this case, to be 0.72, which is 1 minus 0.28. Let's first check that the conditions are met. So we will be looking for the number of successes n times p hat to be greater than 10. And we will check that n times q hat is greater than 10. And then we can go ahead and apply the formula to answer the question. So let's check. N times p hat is 350 times 0.28, and that is 98. And then 350 times 0.72, that will be 252. So both of these numbers are greater than 10. Conditions are met. We can go ahead and try to construct a confidence interval for the true proportion of students who carry their lunches to school. This is what we're gonna do. Start with writing down the formula. So let's first do this using the formula, and then we will check with a calculator. P is between p hat minus e and p hat plus e. We need to find e. The formula for e is zc times square root of p hat times q hat divided by n. We know by now how to find the critical value. Let's just do it anyway. Here it is. Here is the z distribution. The confidence level is 0.95. So right here in the middle, we have 95% of the area. Here we have the negative critical value. Here we have the positive critical value, which means the area to the left is 0.05 divided by 2. To find the negative ZC, you simply use the inverse norm and plug in 0.05 divided by 2. Let's see. Go to variables, second bars, inverse norm, because we are using the normal distribution, and hit paste. And here is the answer, negative 1.9, which means the positive value, this one, is 1.96. So all we have to do now is plug in the numbers. So we have 1.96 times square root of 0.28 times 0.72 p hat and q hat, which are right here, all over 350. And by doing so, we find the answer for E, which is the margin of error. And the answer is 0.05. Now this margin of error should be added to p hat and subtracted from p hat to find the lower and the upper bound. So 0.28 minus 0.05 will be the lower bound, and 0.28 plus 0.05 will be the upper bound. I'll write the answer as an interval. This will be 0.23, and this will be 0.32. So we can say with 95% confidence that the true population of students who carry their lunches to school is between 23% and 32%. Let's see how do we do this problem using the calculator. Here are the steps for doing this problem using the calculator. We will simply follow the instructions. First of all, find the one prop z interval. This is again an interval for proportion. It's under test. And then enter the values. Now here is the catch. They will ask you to enter x, which is the number of successes. We know that x equals n times p hat. And then you have to plug in n and so on. And then you will find the answer. Let's do so together. Stats, under test, let's find the one prop z interval is not on this screen, as you can see. So I have to scroll down until I get the one prop z interval is this option, which is under A. Hit enter, and you'll simply be asked to put x in here. X is the number of successes. In our case, that will be 350 n times p, which is 0.28, okay? Now n is 350. The confidence level in our case is 0.95. And now to calculate, we hit calculate, and we get 23%, about 23% and about 33%. So this is actually rounded to more decimal places, but this is consistent with the formula. Now here is the thing. If the x is not an integer, the calculator will give you an error. In this case, the x was an integer. Number of successes should be an integer. If you have an error, then you cannot use the calculator, or you can just do an estimation, but you need to know how to use the formula, and that's the reason we actually use the formula. Now, let's take a look at what does this mean. Well, this means that the actual proportion of kids who take their lunch to school could be as low as 23.3%. If this is the case, the proportion of kids buying a lunch could be as high as 76.6%. And now we have a follow-up question. If the cafeteria wants to be reasonably sure that all the children who did not bring their lunches to school could purchase a lunch, how many lunches should they plan to make each day? Well, we figure out that this is the percentage of kids buying a lunch because they did not bring a lunch to school, which means that they should plan for 76.7% of the total number of students. How many? This many. And let's see how many is that. Use the calculator to figure out that answer. The answer will be about 269 to make sure they have enough for all students. About 269 lunches. Let's take a look at another example. A survey of 865 voters in one state reveals that 408 favor approval of an issue before the legislature. Construct a 95% confidence interval for the true proportion of all voters in the state for approval. So the given information is we have N 865 and we have X. So this will be the number of successes in this case, which is 408. And the confidence level is 0.95. And the question is, what is the confidence interval for P? Make sure you know that you are trying to find the confidence interval for proportion this time. And all it's important as the true population, that means P, which is a parameter. So how do we solve this problem? We can do it with a formula. I will do it with a calculator. So in the calculator, I will get to one prop Z interval and plug in the corresponding value. Let's do this together. Let's go to stats, tests. I will go up now because I know it's on this other screen at A, one prop Z interval, hit enter, and I will plug in the corresponding value. In this case, we have X, which is 408. We have N, which is 865. And the confidence level, which is 0.95. So we'll just simply calculate. And here we have the proportion to be in between these two values. So 0.44 and 0.50, between 44% and 50% of all voters in the state favor approval. Another type of problem that you will see will be related to finding a formula for the minimum sample size. We've seen this type of problem when we looked at the confidence interval for the mean when sigma was known. In other words, when we used the Z distribution. This type of problem was not seen when we used the T distribution, for the simple reason that we must know the sample size when we use the T distribution. We know that degrees of freedom are very important. Degrees of freedom for the T distribution are based on the sample size. So this type of problem is related only when we two problems or two situations when we use the Z or the standard normal distribution. We are using this when we construct the confidence interval for the mean. So here we have finding the minimum sample size. This formula is actually coming from solving for N in the margin of error formula. The margin of error was this. So if you simply solve for N here, you will come up with this formula. We know that we should add up to a whole number, and there is something else. Sometimes P hat and Q hat will not be given. If that will happen, you will not know what P hat is or Q hat is. Just simply use P hat as 0.5, and of course Q hat will also be 0.5. It's like a 50-50 chance. Here is a problem related to finding a sample size. A federal report indicated that 27% of children ages 2 to 5 had a good diet, which is an increase over the previous year. How large a sample is needed to estimate the true proportion of children with good diets within 2% with 95% confidence? So the given information is p hat 0.27. How large a sample should be? We're looking for n. Within 2 means margin of error is 0.02 and the confidence level is 0.95. To solve this problem, we will simply use a formula. And the formula is n equals p hat times q hat times the critical value divided by e raised to the second power. Do we know p hat? Yes, we do. Can we find q hat? Yes, we can. Q hat is 1 minus p hat, which will be 0.73. So we know these two. Do we know E? Yes, we do. So we have all of these values. And what about ZC, the critical value associated with the confidence level of 95%? We should know that by now. Otherwise, just sketch the graph of the Z distribution. And if you do this correctly, ZC, it's actually approximately 1.96. Plugging in the numbers P hat times Q hat times ZC divided by 0.02, which is E, all of these values, and you will round 1,893. This is how we solve problems related to finding the sample size, minimum sample size, when proportion is given. There is another situation, as I said, when the proportion is not given. So there is no information about the proportion. And if the proportion is not given, let's just create this example right now. If the proportion is not given, example, we don't know anything, we will just simply replace these numbers with 0.50. And I will let you do so. So these numbers are not known. We'll just simply redo the problem. And these are the only numbers that will actually be replaced. And of course, you will get a different answer. Okay? I'll just make a note here. If P hat is not known, make this adjustment. Okay? With this, I conclude the video.